Oh dear me.
I'll let you go.
Ready? Oh my goodness. The Major League Baseball home run distance record is around 575 to 580 something feet, depending on where you get your data. Today on Smarter Every Day, we're going to try to beat that with engineering. We know that major leaguers swing the bat at about 90 miles an hour, and so you get this exit velocity that's really high. I don't know what it is, 100 something miles per hour. We have devised an apparatus. My buddy Jeremy Fielding's been working on it for months now. We've got a 3-phase generator hooked up to a huge motor and a pulley system that gives us the right gear reduction so that we can spin this bat at crazy velocities. We're on this Little League baseball field that I played on when I was a kid. We're gonna try to crank some homers at over 600 feet and see if we can beat the home run distance record. Hopefully we can put one back in those cows. All right, I'm Destin. Let's go get smarter every day. First thing was to get everything off the truck and get it over to the batter's box and begin to line it up and take into account where the sun is so that we could get the right slow motion footage and what angle we wanted to set the bat to. Oh yeah. It's about to get crazy. I'd like to stop and acknowledge the ongoing launch angle discussion. This is an entire field of study having to do with the exact angle of attack that you need to swing the bat at in order to impact the ball at just the right position and get the right exit velocity in order to put these balls over the fence. This is an entire thing. Unfortunately, the reality for us at this moment is that we're just trying to point at the fence and swing a bat as fast as we can. Where are we gonna be, dude?
I don't know, but I want to be outside the fence where everybody else.
If the ball comes off the bat like we expect, then death will be imminent for the pitcher, which is me. Hopefully this will stop any splintered bat and or 200 mile an hour baseball. We'll see. All right, here we go, 80 miles an hour. Let's see if we can hit the bat. So the problem with this whole setup is we have no active feedback because a batter can kind of move the bat as he swings. We can't. So we're just gonna throw it like a ton of times and hope that we get one that just lines up just perfect. Just send it sailing. That's it, money shot, let's do it. What just happened? Okay, low speed swing test. Good.
Yeah, that's about as high as I want to go.
That's good.
I'm standing here.
That, but 200 miles an hour, that's next.
The problem is, Jeremy realized we weren't getting full power from the industrial generator we rented to run this thing. Now's probably a really good time to explain to you who Jeremy Fielding is. Jeremy Fielding and I became friends at ThinkerCon, where we realized we were both dads who loved to build things. Jeremy has his own YouTube channel about mechanical design, and he's really good with electric motors, so it's super fun to learn about this stuff from him, especially when he's troubleshooting the equipment.
I've only got like 30 volts between lines 1 and 3.
So one of your legs is out?
Yeah.
The power that comes out of the wall in your house is called single phase power. It's a sine wave that goes up and down, and everywhere there's a dip in the power, that represents a little spot in time where there's no torque on a motor. Nikola Tesla was a genius, and he came up with a very clever way to get around this. It's called 3-phase power. As one of the sine waves drop down, another sine wave, which is offset 120 degrees out of phase, will be rising. So you always have sine waves rising to cover those gaps in torque. So instead of 3 wires, if you use 4 wires, you can use the Tesla method. You can use 3-phase power and get way more torque on your motor.
So I was right, I was only getting single phase, and that's because it's set to single phase. So that's what we want.
So that's the faster button?
That's the faster button, yeah.
50%, go!
Okay, E-stop is off.
Holy cow. Sounds like a helicopter. You ready? Oh my goodness. All right, grounder, shortstop. Holy cow! We broke a bat.
You broke a bat on the first try.
Well, we didn't get the high speed of the bat breaking. However, it did break where we expected. The stress concentration right here, that's where we expected the bat to break. So if we went that way, then as the bat was bending, that would be in tension. And that's exactly what we have, a tension break. Yeah, okay. 50% power?
I think so. It might have been a little over 50%. I was trying to look at the number and I went past it and was trying to back up, so I'm not quite sure where I ended up.
I didn't tell Trent when to trigger. I messed that up. Okay, so we'll set up aluminum bats.
Yeah.
Okay, aluminum bats. Here we go.
So while Jeremy fixed the machine and attached the metal bats, I decided to work on upgrading my battle station.
So after seeing the wooden bat fly off, we're gonna repurpose this for a little extra shielding. I'm not gonna lie, this feels like the best idea we've had out of this whole thing. Yeah. Okay, here we go, aluminum. Let's do it.
All the way.
Go
50?
75%.
75.
75%. No, just do it, man. Go all the way.
Okay.
All the way.
All the way. 100%.
100%. Scary as junk. Here we go. Oh, dear me. Holy cow. Ready? Oh my goodness.
Did we throw a bat?
It's over the fence!
What?
That was so scary, dude. Okay,
Oh my god.
what failed? The bolts?
I think it did.
No, I think the end of the bat failed and it slipped out.
There's no way the end of the bat failed.
Yeah.
No.
We'll look at the bat, but that's what it looks like. You look at the grip over there, it's still intact.
So
It slid out of the handle.
They're 70%. Hold on.
no.
I
No.
can't believe.
Dude, it went over the fence, man.
I know!
It was so graceful, dude.
It was so fast. I was in shock for a few seconds. Like, wait, what happened?
I didn't even get to pitch at it. Okay. Oh, look. So, whoa!
Oh,
What happened?
yeah, the end of the bat.
Wow.
Yeah, it's still there.
What?
Yeah.
Okay. What? Okay. So, this one's full aluminum, right?
Yes.
Oh. That one's plastic.
No.
Yeah.
Oh, man. Okay.
Okay.
Well, now we know.
Oh, dude, are we done?
Oh, I think we're done. I gotta check that bearing before I spin it up again.
Oh, dude, we're done. We have a home run bat, though. Let's go see the home run bat.
Before we find the bat, let's look at a couple camera angles and see how it got there. In this particular angle, you can see that the bat and the shadow go flying by in just a couple of frames. And it's clear in this shot that my attempt to duck comes well after the bat was gone. And as you can see here, the imbalance of only having one bat left on the shaft really mangled the machine.
Holy moly. Okay. Look at that. It's a home run bat. Like, I don't think we could. It's as far as I can throw it. I can't even make it back to the fence. That's crazy. How far did the bat go?
581 feet.
Are you serious?
Yes.
That's like, okay, Babe Ruth hit, was it 575? Okay.
Yes, that's all.
So we just threw the bat further than the Major League ball record.
Yes.
Okay, nice. Okay, now let's get a ball there. Now, truth be told, there's a tension break here. I should have learned this lesson with Mark Rober when we did the rocket-powered golf club, but I didn't. Where's the club?
Like I'm laughing, but that could have been bad.
The next thing we're gonna attempt here, we have this other bat, and it actually has an aluminum handle. You can tell by filing off here, you can see that that's actually metal. The question is, how is the attachment point between here and here? I assume it's welded, but we're gonna see if we can fix this thing and give it another shot, maybe ramp up 50%, 75%, and see if we can get a homer before we go crazy with it.
So for day 2, we made a bunch of repairs and added an important feature, a wobble switch.
Spinning it up. So if you shake it, so any acceleration like that switches the relay off so that it kills
You
it.
got it.
This time we drilled the handles themselves and put a pin in there to try to keep the bat from flying off the shaft. And once again, I feel like I need to upgrade the safety precautions.
I feel protected now. Okay, everybody's behind steel. Here we go.
Pretty much right out of the gate, at 50% power, we hit a dinger that went right over the fence.
Dinger. Okay, that definitely was not a home run record, but it was a home run. That's 50% speed. right off the end of the bat. So we didn't even hit at the right angle. We're gonna be able to do it.
Oh yeah. When we connect perfectly,
It's gone.
it's gonna go.
Okay.
So we tried to do just that. We ended up pitching and hitting a ton of baseballs.
Homer!
I've played ball my whole life, and like anyone who knows the game well, you can tell what's going on simply at the crack of the bat. Hit it off the bottom of the barrel, and you get grounders. Hit it off the top of the barrel, and you get a high fly ball. Hit it too late in the rotation, you get insane 400-foot foul balls. The bat and the ball were doing things I have never seen at any level of the game. If you've ever played center field, listen to how hard this thing is hit.
Dang, man! Did you see how fast he got to the foul?
We started ramping up the power and things started getting insane. From the mound, it was absolutely terrifying.
Where'd it go?
And on top of that, we started breaking bats.
Time for another bat.
In the majors, the fastest exit velocity ever recorded was around 120 miles per hour. Most players average in the mid to low 90s. Let's take a look at the exit velocities we're dealing with here. On this one, the incoming ball speed is only about 50 miles per hour, but the bat tip velocity is 240 miles per hour, which is nuts. After impact, the bat is still going 183 miles per hour. The exit velocity of this baseball is 190 miles per hour. That is double the average for Major League Baseball. The data is pretty hard to find, but the existing home run records seem to lay down like this. Mickey Mantle's so-called tape measure home run in 1953 went 565 feet. Babe Ruth's shot in Detroit's Tiger Stadium was measured at 575 feet, and Joey Meyer, who played AAA ball for the Denver Zephyrs, hit the longest verifiable home run in professional baseball history at 582 feet in Denver's Mile High Stadium. Because we had damaged all of our bats, we made the decision to just go for it. Full power, 100%, everything we've got. I would now like to submit for your consideration what I believe to be the longest home run in history.
Hey, everybody ready? Yep. Okay, firing it up.
Where'd it go?
It has to be it. It passed. It almost went past the second fence. That's got to be it, dude. Did we break the bat?
Yes.
We broke the bat.
What?
That has to be it.
Where'd it go?
It has to be it. It almost went past the second fence.
It's time to measure how far we hit this ball, only now we don't use a tape measure, we use drones and GPS.
How far is it?
Dude, 696 feet.
Bull, there's no way.
I can check it again, but that's what it says.
696 feet? Yes, sir! That's awesome.
So there you go. We hit what I believe to
Dude,
be
that's
the
crazy.
longest home run in history. And yes, I realize it totally doesn't count because Jeremy Fielding was on the juice. And by juice, of course, I mean three-phase power. I know that's kind of corny, but I get to edit this and Jeremy won't like that, so I'm leaving it in. Okay, so several months ago, I explained that Smarter Everyday is sponsored by Audible, but we went further than that. I explained that required audiobook listening is Skunkworks. This is about the development of the SR-71 Blackbird and the F-117 Stealth Fighter, which are amazing airplanes. Everyone knows the SR-71 is better. However, I have some sad news. So I have data of everyone who went and downloaded Skunkworks. I have to publicly call out some people who did not go get Skunkworks and listen to it, so we're gonna have to do that now. So if I call your name, you need to go to audible.com/smarter or text the word smarter to 500-500 and download Skunkworks. Okay, you ready? Andrew, you did not download Skunkworks. I'm gonna need you to do that. Sarah, Jeremy, did you download Skunkworks?
Yes.
You're good, I'll take you off the list. Noah, Megan, Benjamin, if you did not download Skunkworks by going to audible.com/smarter or texting smarter to 500-500, I'm just gonna need you to do that. Obviously, this is a joke. However, this is an amazing book. I don't know if you know about the development of the SR-71 and the F-117, but it's an amazing story. Overcoming aerospace engineering challenges. You will love this book, I promise you. So please consider going to download that at audible.com/smarter or texting the word smarter to 500-500. You could also get 2 free Audible originals or just get any audiobook of your choice. I mean, there's all kinds of stuff you can use Audible to do to reclaim your time and your commute and get smarter. You're gonna dig it. So, big thanks to Audible for supporting this. Thank you to you for watching this video. I mean, it was really fun, but I'm really excited to have you here. Please consider subscribing. We have a big thing coming up. We're gonna do well, do you want a teaser? Here's a teaser. Yeah, look at that, it's amazing. Okay, that's all you get to see. This is going to be awesome. I would love it if you would subscribe. If you feel like the video you just watched earned that subscription, I would love it if you would do that and ring the bell. If not, that's cool, no big deal. Maybe I will earn it next time, but I think you're gonna dig what we have coming up, and I would love it if you don't miss that. Anyway, I'm Destin, thanks for being here. I appreciate you. You're getting smarter every day. Have a good one, bye.